All right, so yeah, this is the title of this. I'm calling Intro to Helix, although that's not exactly what it's going to be. Because Helix is a very small library, there's not a lot of code in it, so there's not much to talk about. So I tried to find some other things to talk about, and we'll probably go for, I don't know, 20 to 30 minutes is what I'm shooting for, and then I can answer any questions and stuff that people, or we can branch off into discussions from there. So first, a little bit about me. My name is Will Acton. I'm a software engineer at Imperity. Most of you know that here. And I've been developing web applications for Clojure and ClojureScript for about 3 or 4 years. Prior to that, I worked on a bunch of mobile apps and some other single page applications using like JavaScript. And but the point is that most of my career has been developing user interfaces. And I also occasionally contribute to open source stuff. I have a bunch of libraries that I wrote. A lot of them are in Clojure and ClojureScript, and but also like JavaScript and other things here and there. I've been invited to talk about Helix tonight. Helix is a library for developing user interfaces with ClojureScript, and it's one that we've been adopting at Imperity over the last little over a year. To sort of preface, most of the people in the room here work at Imperity, but for those that might be watching at home later, my goal is not to sell you on Helix. If anyone leaves the discussion today and decides to use Helix, that would be great. But really, I want to use this as an opportunity to discuss some of the problems that are in this space of developing user interfaces using Clojure and ClojureScript, and to talk about some of the decisions that I made in Helix and why other people may have decided other things, but specifically why I made those the decisions that I made in Helix. It's a very small library, like I said before, and there are others that do similar things. Names like Reagent, Rum, Fulcro might already be familiar with to you. And like I said, Helix does things a little bit differently, and I think that variety in this ecosystem is very important. So with that, I want to give sort of a 5-minute intro to what kind of the core API of Helix is. And then from there, we'll get into some of the top 3 questions that I get when people first encounter Helix or start to use it. So first, there are 2 big things that Helix provides in its core API. The first is the def_and_see macro, which is a macro that defines a new component. First thing to note is that Helix wraps React, which is a JavaScript library for building user interfaces. And we'll get into a bit more of why it wraps React later, but it's a component-based library. So that means that you write components which sort of encapsulate the behavior and styling and how it's, a widget is structured on the page. And then you render that instances of that component on the page and lay it out how you want. So def_and_see is a macro that defines a new component. It binds a function to a name that you give it, just like defen, but there's a couple of things that are different than defen. One is it always takes, sort of always with an asterisk, always takes a single parameter, typically called props. That's the name that is typically given to that parameter. And you can destructure it just like a map and everything else. But if you were to call this function like a function, which you should not do in general, but if you were to call it like a function, you would actually pass it a JavaScript object with keys and values that you would expect in there. And Helix does some work in the def_and_see macro to take that JavaScript object and wrap it in a map-like thing. It uses Mike Fike's CLJS Bean, library, if any of you are familiar with that. But the point is that it receives a JavaScript object, but in the body and the parameters of the code that you write, you treat it just like a map. And the reason for that is a React component, if you think of it from sort of like a type perspective, it's a function that takes in a JavaScript object with keys and values in it and returns an element. And Helix components are the exact same type signature. That was the goal there. So it just does a little bit of magic behind the scenes to convert that JavaScript object into something that's easy to use for our Clojure keyboards here. The second big thing that it provides is the $sign macro, which is a macro for creating elements out of components. The first argument can be a component that you defined with def and C, but it could also be a string or a third-party component that you've imported from a library. Any valid component type is what the React documentation uses. You can pass into the $sign macro. And then you can optionally pass it a map of props that will get passed to the component, and as well as any children that you want to nest underneath it. The $sign macro returns a React element, which is essentially a piece of data that describes how to render, how to turn that component into like a thing on the screen. The key detail here is that it will shallowly convert your props map that you pass in here to a JavaScript object. And this is what allows you to, you use its maps in when you're using the $sign macro, and it's you get a map when you are writing your component, but there's this translation layer that turns it into a JavaScript object and then turns that JavaScript object into a map, kind of in between. And that's it. You basically know now 80% of what Helix does and how to use it. After you've defined your components and created elements out of them, you can then pass them to your favorite renderer. The React DOM library is one that if you're creating a web application, it'll render things to the DOM in a browser, and it will start your application for you. There's like two other parts of it that are worth calling out, although like they're not really, I don't consider them part of the core API. You might decide to like not use them, and that would be valid. One are the DOM helper macros. There's a namespace called helix.dom, which provides macros for creating like divs and inputs and spans and all that stuff. It's just a little bit nicer to write than to have to write $sign and then a string div and then everything after that. And sorry for the noise. I don't know if you can hear that. Just gonna close my window. The key thing is that React, a key thing that I think is worth noting is that Helix does not know anything about the DOM, and React, the core API, really doesn't know anything about the web or the DOM. The renderer that takes your elements and handles that translation between React elements and the DOM. That's what needs to know about like the platform that you're targeting. So that's why, if you know React, you can write applications that run on a mobile device, like natively. You can also write applications that target the desktop or terminals and stuff like that. That's what's really cool about it. It's sort of like a universal runtime for user interfaces that here we target. But because most of the stuff that I've been doing lately are web applications, I provide a helix.dom namespace to kind of help with that. And people wanted to create a helix.native library to handle like targeting mobile devices, for instance. I think that would be awesome. And then the second thing that it also provides is a set of wrappers around React hooks. And React hooks are relatively recent. I guess they're like 2 years old now, but like the last year has been both 10 years and 3 months for me. So but they're a relatively recent way of managing state and side effects inside of a component. And Helix just has some convenience wrappers around that to make it a little bit easier to use in ClojureScript as well. And so with that, everything about Helix now, basically. And it, in my experience, that is enough to go and build applications using a ClojureScript, and whether they be mobile apps or web apps or what have you. But as because I've been developing apps for in ClojureScript a lot longer than Helix has been around, I've had some experience with other libraries. And when I created Helix, a lot of people, I was trying to sort of like talk about it more, and people had a lot of questions about it. So I want to run through a few of those questions, and then I'd love to hear from some of y'all if you feel like piping in. So the first question that I actually don't get this super often, but I think is something that kind of underpins like a lot of what, a lot of discussions that we might have is like, why would we use React in the first place? Like, why not build something that, in Clojure and ClojureScript that meets our needs, that is really built from the ground up to embody the values that as Clojure developers, we have internalized and also like, proselytized. And I think that's a really great question. And the TLDR for me is like, React is the result of millions of dollars of R&D, just in terms of like dealing with in the DOM or in the web app space, like, dealing with all the inconsistencies between browsers, but also like on the mobile and native space, like handling all of that. And so it's good that we don't have to solve those problems, and being able to pick, whatever render I need for the platform that I want to use is really valuable. And then also it has a lot of mind share that really can't be rivaled by any other, UI paradigm that there is today. Even platforms that, even native platforms like, Android and Swift are starting to adopt a lot of the ideas that have come out of React, and React Native is still like a really big source of income for a lot of people, and also like innovation. And so I think that being able to target that in the same way that Clojure targets the JVM, because we want to be able to reuse a lot of that hard work that's already gone into there. It's also really easy from a like library framework perspective to bind to React compared to a lot of the other libraries that do similar things out there. They're throwing out a couple names that some of you may know, some of you may not, but like Vue and Svelte and Angular or other like common web frameworks for building applications. And a lot of them expect you to be using their compiler toolchain in order to target them. And we really don't want to be in the business, in my opinion, of trying to replicate a lot of that compiler weirdness that they have, or trying to output, what is essentially an unspecified like, bytecode that a lot of them have. And so, with React, the public API is essentially a collection of functions that, it gets data in and it puts data out. And that's our jam as Clojure developers. And I think that React really, it really embodies a lot of the values that we have as Clojure developers. Being data oriented, being immutable, preferring queues over like, push based stuff. All of that is in the bones of React, and I think that we should use it because it works. And then from sort of like a more like speaking more from like the context that I have spent my career in, a lot of the projects that I've built have been in organizations that already have adopted React across many projects. And until Imperity, these other organizations were relatively new to Clojure and ClojureScript. And so being able to take a bunch of developers that were already familiar with React and port over all that knowledge into something new like ClojureScript was very useful. And it continues to be useful, I think, when like at Imperity, when we're onboarding new people. A lot of them have likely encountered React at some point, but may never have used ClojureScript before. And that can kind of ease the learning curve. And then finally, like I said before, UI development is like incredibly labor intensive. And a lot of that is due to the fact that platforms are just kind of spotty in terms of like what they provide. If anyone has ever tried to implement like a date picker on the web, I have. I would never do it again. I would not wish that on my worst enemy. And it's something that as a community, React has just a huge amount of resources to pull from in terms of third-party components, libraries that solve specific problems that as a product engineer, I really don't want to have to be solving. And so we can, just like how Clojure runs on the JVM, again, we can pull from that, ecosystem and use what is useful to us while still being able to develop in Clojure. So that's why React. I do think that there's still space for like, non-React UI libraries in Clojure and ClojureScript. And I know that there are a bunch out there, or there's at least a couple off the top of my head that I can remember. Membrane is one of them, which is super cool. And, there's some stuff that JetBrains is doing actually to like build some like, not web applications, but like native or applications that run on the desktop and mobile apps, which is super cool. But I think that for the context that I've been in, React has made the most sense, which is why, when I was looking around, like, okay, what am I going to do? React. I'm going to wrap React for sure. The next question that I get all the time is why not hiccup? It's a good one because, like at Imperity, we are sort of migrating from using Reagent, which uses this syntax. Hiccup syntax was popularized by a library called Hiccup, but it's this syntax where you sort of represent trees of data as nested vectors here. So you can see like this is some HTML that's represented as a bunch of vectors that are sort of nested within each other. And it's a joy to write. I love it. And it's a really sort of natural way as a Clojure developer, especially if you have like Paredit or, all of the fancy IDEs to like, write HTML or other tree-like data structures using this. And so why not, expose that in, why not provide that out of the box in Helix? And the reason why is because it turns out that it's a real pain in the ass for computers to parse. This sort of goes into the history of Helix, but I actually started out Helix under a different name where I was trying to write a hiccup parser that took hiccup syntax and turned it into React elements. And what I found was that sort of my naive attempts at trying to do this at runtime and have it work with sort of like, third-party components as well as components written in ClojureScript, that it added about a 3x slowdown to the time it took to create all those elements compared to plain React. There's definitely like faster, like reagents hiccup parser is much faster than that. I think it gets up to like after some changes, like I think some improvements were made recently, but I think it's up to like about 80% as fast as React. Don't quote me on that, but it's really close. It's really fast, but it still like frustrated me at the time that any application that I wrote using my library was going to be slower than if I had written it in JavaScript. That just sort of like offended me. And so I explored some other avenues as well. I explored like compile time parsing. So trying to parse all of and generate all of the JavaScript data structures that all of the React elements, I mean, at compile time rather than at runtime. And there are libraries out here that do that. One is called hiccup. And then there's another one that I wrote called Thump, which actually uses reader tags to do that instead of like macros. But I ultimately found it frustrating and confusing that, you know, if I changed like one or two things, like one or two minor things, seemingly minor things in my code, in my component, that it would have to fall back to using runtime parsing and interpretation, and that it became harder to reason about the performance of my components. And then on the flip side, like if I tried to sort of, you know, enforce more explicit patterns that were amenable to compile time parsing, it felt like I was missing out on all of the benefits of using hiccup syntax in the first place. Like I might as well just write parentheses instead of, you know, square brackets and like, you know, call them like a function or a macro. And so ultimately I decided to pivot, and that's where Helix got extracted out of that library. And so I was like, I'm just going to provide a few macros for creating and defining elements easily, and for creating elements and defining components easily. And then if people want to, if other people start to use this library and they want hiccup, then they should be able to adopt that, like sort of a la carte. This works. For instance, like my old hiccup parsing library, which is called HX. You can use it with Helix. And I think that this is like an open area for development. If people are interested in using Helix and hiccup together, you know, talk to me. I'd love to, you know, I'm not interested in using hiccup right now, but I'd love to help people out if people are interested in creating their own library that handles that. So that's why not hiccup. The next question that I get all the time is what about state management? And oh boy, do I have a lot of thoughts here. Not all coherent yet, so I apologize. This is going to be a bit of a ramble, but you know, one thing that I've sort of like snidely replied with is, what even is state management? Like what is that? There, and to try not to be like too flippant here, but like in no other area of software development do we have a whole sub industry of solutions that are like one size fits all for quote state management. And that is sort of that's a signal to me that like I might be thinking about this problem wrong if I'm looking at this, trying to solve state management as a whole for my entire application using one thing. You know, instead we have things like databases and caches and volatiles and atoms and, you know, things that like have like specific mechanical properties that we pull into our application or our services sort of as needed. And a lot of times there will be multiple solutions in the same service, right? Like we might have a database for storing, account information, and then we'll have like, an atom or a volatile for caching things, and like, stuff like that. And so, the real truth of it is like, when I'm like sort of being flipped there is I just don't know what a good default solution to this looks like. There's a couple of different like concerns that if you start to tease apart, like, well, how should I manage state? Like, one of the heuristics that I've started to use when thinking about how and where to store state within an application is to interrogate what I know about the data's lifetime. So like a lot of state, for instance, like the input values of a form only exist when the component is shown on the page. And it shouldn't exist anytime after it's gone away. They've navigated away. And so it makes sense to, if we think about places for a moment, it makes sense to store that state as local as possible, like in the parent form component, or maybe even in the DOM itself. Like, don't control that state in like some state management tool. So that and that way the state always reflects what is rendered and is evicted when it no longer is shown on the page. Other pieces of data, for instance, like a network payload that you want to cache, you want to keep it so that we don't have to keep refetching over and over again. That might live beyond the lifetime of whatever's currently on the screen. And so we probably want to store that somewhere a bit more durable. We would want to store that like maybe in an atom, or maybe in local storage, or maybe in a web worker, but like it's going to live outside of that component's lifecycle that is fetching that data. And we also then have to start thinking about like, well, when do we evict that data? When do we, like maybe it's when the user does a certain action, maybe it's, maybe it's not until they reload the page, but there's like concerns there that are very specific to that problem of data fetching that really aren't present there when we're talking about forms. And so that's why, in my opinion, I started to think more about, what are the specific problems that I'm trying to solve in my application, and how can I build solutions to that problem that, or pull in solutions to that problem from elsewhere that meet those needs. And then they probably have state underneath it, but like that state might be stored in different ways or different places using different containers. So things like navigation is like one that's pretty obvious. Like, we could have like a Helix navigation library or something, or we could just pull React navigation down from the internet. Like data fetching is another one that I think is like requires its own sort of like special solution. Forms is another one, and you could theming is probably like a fourth one that all require like their own kind of specialized solution in my experience. There's one, or there. I will also say that like the out of the box state management tools that React gives you, React hooks or component, or if you have to use a class, like using the methods on the component class, although I wouldn't expect anyone who's using Helix to do that necessarily, but those are actually like pretty good as like a starting point, because it does sort of it ties that lifetime of the data that you're storing in there to the lifecycle of the component, which a lot of the times is correct. And one of the other nice properties about that is you get, what's the best way to explain it? So I guess one thing, because I think I can fit you all on my screen. And show of hands or what have you, anyone know what a virtual DOM is? Or should I explain that? I didn't get everyone's hand, so I'm gonna do a quick explanation of the virtual DOM. So React is uh, React is a library that it's sort of like mental, its big selling point, I guess, its mental model is that when it renders your application, it doesn't actually change the DOM or anything on the native platform if you're using a different renderer. What it does is it generates an immutable data structure that represents the entire like component tree of your application. So all of the elements that make up what is currently on the screen. And then if you're updating like what's on the screen, it's not like a new, you're not just starting it up, then what it will do is it'll generate the new immutable data structure, and then it will do a diff between what was just generated and what was used to render the screen before. And in that diff, it then comes out with like a set of instructions that it then uses to go and actually do all of the like mutable like banging on like DOM elements on the page, for instance. And so this like should sound really great from a Clojure developer perspective, because it's like all immutable data structures. We've got this efficient diffing algorithm, and then the mutability is sort of like the end product of this pure immutable process. And one of the things that the default state management tools like React hooks do is they store the state of whatever data that you're controlling with that in the immutable tree that you are using to do that process, which means that you can't ever end up with a state, well, state is maybe like an overloaded word at this point, but like you can't ever end up in a coincidence where the state of your application is different than the immutable tree that is being rendered at that point. So if you were to, for instance, like store some data in like an atom that lives outside of the tree of components that are currently on the screen, and you change that atom, then at some point you want to generate that new immutable data structure that represents what is currently supposed to be shown. But there could be a period of time where they're different. And this becomes important. It's not super important. It's becoming more important. They just came out with a new version of React that allows you to opt into what is called concurrent mode, which sort of very basic explanation is that it allows you to reorder the updates that you are doing based on priority. So if a user is like typing on the keyboard and that should update the screen, that's a high priority update. We do not want to have the user sit there and wait to see characters on the screen or something like that. But we might be willing to wait a little bit longer if we're re-rendering our application based on fetching some data. Like we could, fetching some data that's going to take, I don't know, 100 milliseconds, maybe more, waiting like 10 more milliseconds or 20 more milliseconds or what have you is not going to be a big deal. And so we would reorder those updates so that we do the high priority ones first and then the lower priority ones. And they obviously have a much smarter algorithm than that, but the point is that things might come in out of order. So if, for instance, you are in response to that data fetch, you change an atom and then trigger a render, and that render is low priority, then it might not get run immediately after changing the value of that atom. We would want it to in this case. So we would have to tell React, or React would have to detect that like, this state is being managed outside of the React tree. We cannot use this more efficient algorithm, this more efficient scheduling algorithm. But if we did try to use that, then there might be high priority updates that are triggering renders to subtrees that also refer to that atom. and that would cause there to be a mismatch of like, you might have some parts of the screen up here that were rendered using the old version of the atom, the old value, and then other parts of the subtree that was triggered by the high priority update could be seeing the new value of the atom. And so you end up with the sort of term of art there is tearing, where you have this mismatch of states on the screen and in the immutable tree. So if you use React's state management tools, you don't have to worry about that. You get that for free, and you can use that more efficient scheduling algorithm to do things. And they're very careful about like not breaking our apps. So like our apps aren't going to suddenly be like, running updates out of order. The new scheduling algorithm is opt in, and you can use it just when, it is known to be safe, but it's something that, as user interface developers, as, application developers, I'm thinking about, because I think that could greatly benefit the user experience that we provide in our applications. So that's my spiel about state management. Long and rambling, I know, but and I lost my notes. There they are. Great. So, all right, I know that I'm running a little long, so I will wrap this up with the last question. That I get this more from people who are the people that like aren't coming from a closure perspective. They're usually people that have been doing React for a while and are getting up to speed on closure and closure scripts, or interested in closure and closure scripts but aren't totally sold on it yet. And so one might ask, like, why not just use JavaScript? Like in this entire talk, I've been sort of lambasting a lot of the features that are really cool, right? Like they're features that I think set us apart from our JavaScript brethren. Things like hiccup and like better or fancier state management tools and stuff like that. Like, what value proposition do we really have if I'm sort of saying that, like, well, let's not include that out of the box? And I think that in my opinion, if we look at Helix and ClojureScript as a package, that there's still a really good value proposition there. Like just from a language perspective, things like immutable data as defaults, Eden, you get a fantastic standard library, and a pretty decent macro system, and all of those have all of those make a fantastic base for application development. And if we wanted to get those in JavaScript, we would have to sort of cobble together a bunch of different libraries and tools, and it's and those aren't used like throughout the rest of the ecosystem. So you have to kind of like figure out, okay, how do I make this other thing that I now want to pull in work with all of the rest of the stuff that I'm doing? And it's like just managing the build tooling of a JavaScript, a really large JavaScript project could be like a full-time job. And so I really want to avoid that. And so that's why I think that ClojureScript and Helix really in the larger ecosystem of user interface development still has a spot there for people that see that as valuable, and like I said, immutability and macros and other things. Helix also, like, there's a few features that have come out recently that are building on top of the core that I think are examples of like how Helix can sort of push beyond what the standard developer experience is in JavaScript. For instance, one of the most recent releases enabled static analysis of your components to detect if you're misusing React hooks, because there's these rules that you need to follow when you're calling React hooks. You need to make sure that they're not in like a conditional or a loop, just due to some like sort of quirks in like the way that React just has implemented them. And so it will emit a compiler warning, a closure script compiler warning, if you are breaking one of those rules, which has, I enabled it on our code base at Imperity, and it had like, I don't know, maybe a dozen different warnings that, could have been bugs that hadn't been triggered yet. And so I went through it and fixed them all and then merged in. And, we have that as a tool now that, normally would require probably a linter that would need to be set up in CI and would need to be installed on everyone's box. And like, instead, we just get that as part of the Helix package as a library. The other sort of like cool feature that haven't completely decided if it's a good idea yet is automatically detecting and using the same static analysis idea, automatically detecting and emitting dependencies when you're memoizing values. It turns out that using React hooks, you end up memoizing a lot more than you did before, mainly because if you're using a lot of React hooks, you're probably triggering side effects based on whether a value has changed from one render to another. And the way that React does that is using essentially an identical check. So it checks to see like, is this value identical to another? So if you're recomputing that every render, then that's a new value, but it might not be semantically different, right? You might have, it might not be a truly different value. And so you typically fix that by memoizing it, but typing in all of the dependencies on when it should recompute that is like super tedious. And so Helix can do that for you if you opt into that. And all of those things are things that, again, like different parts of the JavaScript ecosystem has sort of started adopting things similar to that, but it's like tool hell when you start to do that. And I am trying my best to avoid having to go back to configuring two different linters and Babel transforms and sweet macros and all the things that are required to get this power in JavaScript. And so that's really, why I find Helix a joy to use compared to the JavaScript experience. And with that, I will open the floor. If people have questions or if we just want to hang out and chill, then feel free.
I have one quick question, and I actually have to run real quick. And it was back to the one that infuriated you the most, the state management.
Yeah.
If state management is so hard to maintain, why don't? And I'm coming from the very lack of knowledge on the whole UI development. Why don't React or Helix or any other of these tools exploit more the capacities of the browser for local storage or SQLite or stuff like this to store the state of the app? I mean, I'm not that concerned about the state of each component because they can manage their own state more efficiently, but the state of the entire app, why don't we use more like local storage or have some wrapper around local storage, SQLite, or whatever the browser is offering?
Yeah, that's a good question. I think a lot of, just to talk about like local storage and other sort of like more durable forms of like storing information in the browser, there's a lot of limits that browsers implement that, you can't just sort of throw everything into local storage. I can't remember the limits off the top of my head, but it's a relatively small amount of data in the grand scale of things. I think it might be like, it's on the scale of megabytes. So like we wouldn't, for instance, want to put like a, a time series data set, or like a data set that we're doing like analysis on, like in the browser or in local storage, for instance. We might want to keep that in memory, but we wouldn't want to put that in local storage. And so that's kind of what it comes down to, is that there's different places that you'll want to keep different things. Like user preferences is something that makes a ton of sense to store in like local storage or cookies, so that it persists across sessions or reloads at least. But other things don't belong there, either because they don't fit or because the lifetime of that data just doesn't belong in something that we can't, that either we can't control, or if we can, because we can with local storage, like the cost of like having to go to disk and then read it back is just like, it's not worth it, right? Does that make sense?
Yeah. I mean, having to use Helix and Reagent, working on any interface with Helix is a breeze, and even the code looks a little bit more intuitive than Hiccup to me. That my experience with Clojure is only 4 months.
So I have a question. So in general, whenever you wrap something, there will be somewhere gonna leak. So just have you see any place when you use Helix that's being awkward when you because you're wrapping, right? So like being awkward when you use it.
Yeah, I think that I'll refer back to something that I said earlier, which is that React is actually like really easy to wrap and or to bind to is I think what I said, because it's basically data in and data out, and so you can kind of like futz with that how you will. What tends to be leaky, I guess, is sort of like, what data do you put in and what data do you get out in every circumstance. So like one of the things that I started off with was okay, so when you pass in props to a DOM element, if you're building a web application, when you pass in props to it, React expects it to be in camel case. So like, on change, in nice Clojure like idioms would be on dash change, right? But React expects on and then uppercase C and then et cetera. And so at first I implemented that in the $ macro, where I said that, okay, if you are using $ macro with a string as the first parameter, so you're ostensibly rendering I called it a native element at the time, or a native element type, then it's going to do that conversion from kebab case to camel case for you. And that actually ended up being wrong, because two things. One, some element properties actually ended up being like, you want to pass in kebab case. So, okay, I had to special case those. That's annoying. But then it also turns out that other platforms like React's native have different sort of like ways of converting things, that you want to like, change the names of things or parse things as into arrays instead of like passing them in as vectors from a convenience sake. And so I started to add more and more of that to the $ macro. And then I was like, this is actually like, I'm just adding a bunch of special cases depending on if I can guess if they're targeting the web versus if they're targeting, mobile devices versus like, people were trying to use Helix with 3GL, which is like a really cool library for creating like 3D like art and models in the browser. And it had its own idioms that like, they were asking for me to add to it. And I was like, no, I got to stop all this. So I'm slowly starting to migrate that sort of like converting between kebab and camel case and like other conversions that are not just like taking this map and turning it verbatim into a JavaScript object. I'm moving all of that out into special case macros. So instead of doing $ and then a div in quotes, you would do $D and a div in quotes, or you might have a $RN for React Native and $view or pass in a view component. And so that is sort of like it was just like a mismatch between like what I thought the semantics were or what I thought the pattern was for converting these data structures into the data structures that the renderer expected and what they actually ended up being. So that's one of the things that before I hit 1.0, that's my goal, was to solve that problem.
That's an interesting problem to have.
I was actually curious. I don't expect you to have an answer for this because I doubt that you've worked much with React Native. But we were going into React Native. Do you have some sort of sense as to the sorts of things that React Native is capable of today? My understanding is that originally it was primarily a way to get a solid framework set up for yourself to develop the UI on a mobile device, but it didn't give you the ability to reach into the APIs if you had something that was more that if you wanted to access some sort of functionality that was on the mobile device. So for example, if I wanted to do something a little bit more device specific, using a specific camera on a specific phone, that's something that you would normally only be able to have access to inside the standard Android API or the standard iOS API. It was not something that was standardized with React Native, where React Native is really focused on just the UI portion of taking care of some relatively simple mobile apps, and then maybe having you write some native code on the side that it shelled out to as necessary.
Yeah, I actually, I spent like 2 years building apps using React Native, but that was back in like 2016, 2017. So things have changed since then. I know that. I think that the answer is always going to be that just like in Clojure, how sometimes you have to roll up your sleeves and get your hands dirty with some Java development. That's also going to be the case with React and React Native, especially. Like one of the things that I know is that there's been this this change in. So when I was doing React development, what was really difficult was that problem that you were talking about. Like I want to use a specific camera on a specific device, or some device specific like hardware feature. It would be great if we could distribute that as a library, so that I could just install some module that provides that functionality. Maybe it doesn't exist, so okay, I'll go write it and then I can distribute it to people. But that was really difficult because back when I was doing React Native development, because a lot of times it involved having to install these native modules and this JavaScript package, and sort of like including that in my build process was really complicated. Nowadays, I get the sense that like with Expo and some other like third-party tooling, that's really, really easy. And then also I know that React Native recently has gone through a big re-architecture where before, I remember this because I wrote a bunch of like native modules that like did exactly what you were talking about. I like wanted to use some on-device feature that wasn't exposed using the React Native sort of like basic API. And the way that the two platforms communicated, right? So you have this JavaScript process that's running on the device, and then you have this native process that it's embedded inside. But the only way to communicate between them back then was through message passing. So you had to like pass a message over the bus from JavaScript, and then you'd have to pass their message, from the native side. That was really, really error prone and tedious and everything. Now they have a synchronous communication pattern that you can go back and forth from. So you don't have to do as much of that it was a lot of boilerplate and very error prone the way that it was done before. So now, but I think that through that makes it easier to develop these native modules. And with the tooling that has grown out of that to like distribute native modules in a much easier fashion, I think that there are some fairly complex applications out there that are built using React Native. Like the first one that pops out into my head, because I know that they use ClojureScript for sure, is Vouch. Vouch is the company that Dave Nolan and Mike Fikes is working at right now, and they're interfacing with like Bluetooth and communicating with like these external devices, and they definitely are having to use the device not just as like a thing to show like stuff on, but also like using it as a hardware. And if it's working for them, I'm sure that would work for a lot of other use cases as well.
Okay, that's exactly what I was getting at. Thank you.
Great. And just a heads up, I have a hard stop in about 7 or 8 minutes. So I hope that gives us enough time. Yeah, I really appreciate all of your attention, by the way. And yeah, this has also been the first time that I've ever talked about my open source development in public. So I was pretty nervous about this time last night, where I was like, oh my God, I'm gonna have to actually talk about this stuff out loud. How horrible. And you all have been very great listeners and a great audience. I really appreciate it.
Glad it's been a positive first experience.
Thanks, Greg. I just look at your corner of my screen. I'm like, yeah, Greg looks like he's getting it. I'm doing a good job right now. You might just be jamming the tunes though. What do I know?
No, I will say that ClojureScript is definitely the most enjoyable UI programming I've ever done, and Helix has definitely been a nice, simple interface with React on top of that.
Yeah, I think if there's anything that I would add to Helix at this point that isn't already very much present, one thing that I've had, people have asked me about it before, and I didn't include it in this talk because I didn't think about it at the time, but server-side rendering is something that I think the Clojure solution to that could be very attractive, even to people that aren't already using Clojure. I mean, Clojure and ClojureScript already has this idea of you can use the same language with you know, it's not exactly the same, but like similar semantics and like same syntax on like both the back end and front end, and you get the power of the JVM on the back end and like, you know, all the reach of JavaScript on the front end. I think that that's still a really like interesting and persuasive story. And Helix doesn't provide anything for rendering things on the JVM. There are other libraries that do. Rum is one of them, that you can like render static HTML out of your, you know, components on the back end, and then use those same components on the front end to render like dynamic applications. And the React proper has actually been doing a lot of work in that space, where they've now been working on a protocol for streaming changes to the application, instead of sort of like having this sort of like one shot, like you go and request all of the static HTML, and then once it's rendered on the page, now it's like all client side stuff. Now they have this what they call server components, where when you click a button or do some sort of like state change, if in that update that there exists a server component in that tree, when it's in the client code, that component will essentially be a stub, but it will tell React to reach out to the server and say, hey, render what this component should be, and then send the HTML down of what it should look like. And it's very novel. And like the novelty in that is actually like, well, if you're running the code of that component on the server, like now you're in like a trusted environment. Now you can run like database, you know, queries. You can, you know, do things that like are, if you're doing that on the front end, you have to sort of route that through an API, and then like you do all this like stuff. But you know, it's just like kind of like more action at a distance. But with server components, you know, you can do more of that. You can encapsulate more of that behavior in the component itself, which I think is really cool. And it's something that we could definitely provide from a Clojure library, but we would just need to like understand the spec, which they haven't defined yet. And so I'm kind of waiting. I'll probably be waiting for a few years before I finally get around to that, but I think it's cool.
Interesting. That kind of makes it seem more like treating the browser or whatever client as like a really dumb thin client, that you're just like doing the heavy lifting on the back end and just giving it stuff to render.
Yeah, I think that you can definitely do like, there's another library, not in Clojure or React, but it's an Elixir library called Phoenix Live View that people have been chattering about a lot online for a while. And it's essentially that, where your web page opens a WebSocket to your backend, and then any clicks or anything is just like, it's going to send a message to the backend and ask for and it's going to stream the HTML to you. And it's treating, like you said, like the browser as this very thin client, kind of the thick client that like a React app would be. There's like trade-offs to that though. So yeah.
Yeah, I guess the downside is you immediately lose any kind of resilience to network connectivity loss.
Exactly. And yeah, exactly. So I think that there's probably a middle ground there, which I think is what React is trying to do with server components, where they can kind of have their cake and eat it too, where the sort of the default is that like you're doing everything client side, but then as soon as like when it's rendering the tree of components, it hits a component that it knows is a server component, then it can kick off that request to like, okay, now let's go and, you know, do that processing on the back end. And using like the concurrent mode that I was talking about earlier, you know, it can have that rendering of that tree sort of like paused and waiting, and still be doing other updates. And then eventually when that, request comes back with that fully rendered view, then it will resume rendering the rest of the tree, which is the dream, I guess. All right, with that, I turn into a pumpkin. So it's 8:15. Yeah, I appreciate the time. Thanks for having me. And yeah, hit me up on, I'm Lilac Town on GitHub and on the Clojure and Slack. So if you want to talk more about this, yeah, hit me up. Thanks.
Great.
Thanks a
Thanks,
lot, Will.
Good night.